Okay, we're going to do, these are the 3.7 notes, inverse functions, page 3. We're going to do two things on this last page. We are going to consider inverse functions and values from a graph. We're also going to use the composition of functions, which is going back to section 3.4. We covered that in like week 2, if you need a review. To show that two functions are inverses, okay? So first things first, example 8 at the top, we're gonna use the graphs to evaluate. And I am gonna go back to page 1 really quick and what I wrote at the bottom of the page. I know that if f of x equals y, then f inverse of my y equals x. And so as we look at these graphs, we are going to think in terms of an ordered pair and the point xy and go from there. So I have two functions, f of x and g of x. A wants f inverse of -4. And so here's how I want to think about that. I'm thinking of it as f inverse of my y is going to give me an x. So looking at function f, which is the one on the left, I'm actually looking for where y is -4. And so here is the point for -4. When y is -4, x is +4. So f inverse of -4 is +4. B, I want g inverse of 0. Again, I need to figure out where y is 0. So we're looking at this the same way. G inverse of y is going to equal x. And so where is y 0? We've got this point right here. -2, 0. Sorry for the delay there. I was having trouble thinking. So when y is 0, x is -2. So C, we want g of f of -4. And this is going back to what we did with compositions of functions. I want f of -4. So that says when I plug in -4, I get out +4. So f of -4 equals 4. We're now going to go over and look for g of 4. When I plug in 4 to function g, I get 6. So now we want the composition of g and f inverse of 2, which means I want g of f inverse of 2. F inverse of 2 says, where is y2? I got this point right here. When x is 0, y is 2. So f inverse of 2 is 0. I'm going over here. When g is 0, when x is 0, g of 0, y is 2. So here we get 2. E down here, I've got f inverse of g inverse of 6. So that says when y is 6, what's x? That is this point over here for 6. So g, actually I'm going to write it below, so I can just replace. G inverse of 6 is 4. Now I want f inverse of 4. That says when y is 4, what's x? And that's this point over here. We get -4. And that's that. Sometimes you got to slow down and think about exactly what you are being asked. Example 9, we are looking at the composition of functions here. So if function f is 1-to-1, then f inverse is the unique function such that the following hold. Basically, it says if we do one and then the other, we get what we started with. So if I'm plugging in x to 1 and taking that answer and plugging it into its inverse, we should get x back. We should get what we started with. So which direction do we want to go? It doesn't really matter. We could go either way. Let's go f of f inverse of x. This says when I plug x into f inverse, I get x minus 8 over 5. That is the input for function f. So I've got 5 times x minus 8 over 5 plus 8. My 5s are going to cancel. I get x minus 8 plus 8. I get what we started with, just x. Let's see if that works for us if we go the other direction, because it's supposed to, right? So I've got f inverse. This time my f of x, when I plug x into f of x, I get out 5x plus 8. And I'm going to plug that into f inverse, which basically is 5x plus 8 minus 8 all over 5. I get plus 8 minus 8. Those cancel out. I get 5x over 5. We're left with just x. B, here we're using those rational functions again. Not sure if it matters which order we do them in. I want to go f inverse of f of x. Not sure why, that's just the way I wrote it down. F of x is 1 minus x over x. We plug that into f inverse. I've got 1 over 1 minus x over x plus 1, which looks somewhat unpleasant. I want to eliminate the denominator in the denominator, so I'm going to multiply everything by x. I get an x in the numerator, and I'm just going to write this out really quick. X times 1 minus x all over x, plus 1 times x is x. I get x over, my x's cancel here, 1 minus x plus x, which gives me an x over 1, which is x. You only have to show this one direction. What I would suggest is if you do it one direction, you're not getting what you think you should get, then go ahead and try it in the reverse direction just to confirm they are inverses, and then come back to your original composition, see if you can figure out where the mistake is. And that is it for section 3.7.